Okay, here we go with solving exponential equations. So you will notice that everything that you're supposed to do is numbered for you. You have numbered steps, okay? Use the property of exponents to simplify each side of the equation. Meaning, if you need to add something together, like on number 4, we'll get there in a second, where it has 10 to the negative 4th times 10 to the 9th, combine those to make them 10 to the 5th. Okay, so simplify it first. Number 2, rewrite the equation so both sides have the same base. Further down into your notes, you'll see where your bases aren't always the same. I'll go over that more, but that will be step 2. Step 3, drop the bases and set the exponents equal to each other. That's what you're actually going to solve. So these look a lot harder than what they are. So once you have the same base, all you do is drop the exponents and set them equal. So like on number 1, we have the same base, 2 and 2, right? So we drop the exponents, set them equal to each other. X plus 1 equals 9. Subtract 1 on each side. X equals 8. And that would be your answer for number 1. On number 2, still doing the same thing. We have 5 and 5. So we drop the exponents. 4n plus 5 equals n minus 7. We solve that and we get your answer. So first we're going to get all your n's on one side. So 3n is equal to negative 12. So n equals negative 4. Okay, so if you have the same base, it's pretty simple. All right, now look at number 3 and let's look at the difference here. So what you'll notice is that we have 3 and 3 on the same side. So it's not simplified over here. So what we're going to do is drop all of these bases first. Since we have the same base, we can skip to that step. From there, we're just solving the equation. So it's pretty simple as long as we have the same base. We just drop all our exponents, solve your equation. Once you combine like terms and solve that, you will get 1 equals k. Now I want you to pause the video and do number 4. All right, so for number 4, you should have gotten v equals 4. So in order to do that, all of our bases are 10. So we can skip straight to dropping our exponents down. Okay, from there we're just combining like terms. And solving our equation. And we get v equals 4. Okay, so for the rest of your notes, I'm going to do the odds, and then we'll go through all that, and then I want you to try the evens, and I will upload the key to this so that you can check the evens and make sure you're doing it correctly before you go on to your assignment. So look at number 5 first. You should notice that our bases are not the same. Okay, so normally one of these, it will be kind of obvious for what you can use. So like 6 to the 2x minus 10, we want to change our bases to the same, like it says on step 2. Rewrite the equation so both sides have the same base. So 6 to the 2x minus 10, sorry, sometimes it's hard to write on here, equals 36. So what is 36 if you have 6 as a base? 6 squared, right? So 6 squared. We'll go right here. From there, we're back to what we started with in your examples above. So we have the same base. So we're just dropping down our exponents and we're solving our equation. Okay, so we add 10 on both sides. and we're left with 2x equals 12, so x equals 6. Okay, next we are going to look at number 7. In this case, we have 7 as a base, and we have 1 over 7. Now, if you think back, in order to get 1 over 7, we can do 7 to the negative 1. So if you have something like this already as a base, then just think, what can I do to the second number to get a base of 7? Okay, and it's turn it 7 to the negative 1. So from there again, once we have the same base, we can drop our exponents. And then solve your basic equation, and you will get x equals negative 3. From there, it's just a two-step equation. Okay, so for number 9, we're going to look at our base of 27 and our base of 3. Again, normally one of them, it'll kind of give you an idea of what you can use. Okay, so we have 3 as a base. Can you think of anything with 3 as a base that will give you 27? It's 3 to the third power. So unfortunately, there is no rule you can use to find the common bases that it's just a uniform rule that'll work every time. A lot of it is just trial and error. You just have to play with it and see what will work for common bases. So 3 to the third is 27, right? So we're going to say 3 to the third to the 2x plus 6 power equals 3 to the 2x power. We'll stop there for just a second to make sure everybody sees what we did. We turned 27 into 3 to the third, and we just brought down that exponent. And then we did 3 to the 2x power. We just brought those down since we had the same bases. So now we are going to use the power rules that we talked about. And we are going to multiply 3 times everything on the outside of this right here. Okay, so it's not distributive property, but think of it like that. So, because our power rules, when you are raising a power to a power, is you multiplied. So, we're ignoring our bases because they're common now, so we're just dealing with the exponents. And we're going to get 6x plus 18 equals, all we have over here is 2x, so it just comes down. So, from there we solve. 18 equals negative 4x. We divide by 4 on both sides, and so we get negative 9 over 2 equals x. Because 18 divided by negative 4 does not go evenly, so we just simplify that fraction, and that's how we get negative 9 over 2. Okay, so let's keep going with number 11. So if you look at these, we have 125 and 25 as our base. So neither one of those is small enough to really be our common base. So think of something when you raise it to an exponent that could give you 25 and 125. Can anybody think of what that would be? 5. Okay, so 5 to the third is going to give you 125, and we're going to raise it to that y power equals, sorry, it's so hard to write on this sometimes, equals, and then 25 will be 5 squared. Okay, let's recap again. So 5 to the third power is 125, so we're just bringing down that exponent that was already there, and then equals 5 squared for 25. So then we're using our product power again here, and we're doing 3 times y is 3y equals 2, because that's the only exponent we have on the other side. On the 5, we just have the 2, so we bring it down. Then we divide by 3 on both sides to get y by itself. So y equals 2/3. Okay, for 13, we are going to approach it the same way. So, with 4 and 8, can you think of a number that would be a common base that can use exponents to get to 4 and 8? 2. So 2 squared would give you 4. And we would raise it to that 3x power. And then 2 to the third would give you 8, right? And it would raise to the x minus 1 power. So from there, we just have to use that product property, and we would get 6x equals 3x minus 3. Because remember, once you have actually gotten the same basis, we're just focusing on our exponents. The bases go away. Then from there, we just combine like terms and solve. So we would get 3x equals negative 3 and x equals 1. Okay, we start 15 the exact same way. Again, 8 and 32. 8 comes to mind, with 8, 2 comes to mind, 2 to the third power. So I would just check with 2. We know 2 to the third is 8, so check with 2 to the fourth, 2 to the fifth, and 2 to the fifth is 32. So we can use those again. So 2 to the third raised to the 2a minus 1 equals 2 to the fifth to the 2a plus 1. Okay, so again, we just used the 2 to the third and the 2 to the fifth to replace the 8 and the 32. Now that we have common bases, we use the power properties to bring our exponents down. So we have 6a minus 3 equals 10a plus 5. And from there, we just solve. So we have negative 4a minus 3 equals 5, because we got that from moving 10a over. Then we're going to move 3 over, and we will get negative 4a equals 8, and a equals negative 2. All right, so now let's look at 17. When you first look at this, it can look a little confusing because we have multiple numbers over here, but they have the same base, okay? So don't stress about that, but we still need the same base on everything in our equation. So will 4 to any power give us 64? Yes, 4 to the third will give us 64. So you're going to replace this 4 to the third, and then you're going to go into this normal 4. So if you just have 4, what is the power? 1. And then you have 4 to the 4x. We're just going to bring that down. So the first thing we did was get all of our bases the same on our exponential function equation. Then from there, once our bases are the same, we are going to just drop your exponents. So 3 equals 1 plus 4x. We know it's plus because it is a positive 4x exponent, okay? Just follow the signs just like you're used to. Then from there, we are solving. So 2 equals 4x. And then we divide, and we get 1/2 equals x for our answer. Okay, so the last one that we're going to do together is number 19. It can look intimidating when you first look at it, but it's not that bad. Remember, we said with not an exponent, excuse me, we said with a fraction, that can be written as 7 to the negative 1, right? Then we have 49. Well, we know we can use 7 for a base of 49, so we're going to do 7 squared, and then bring down the exponent. And then we already have a base of 7, so we just have 7 to the x minus 9. Okay, so from there, we just have one section to use those power rules, and everything else is just going to drop down. So we have negative 1 equals 2x minus 10, and then plus, because we have a positive x, so it's going to be plus x minus 9. From there, we just need to combine like terms on this right side and solve our equation. So we have 3x minus 19. And so 18 equals 3x. So what does that make? X. 6. Okay, so Again, think about the first section. The big thing is finding your common base. If you don't have common bases, find them. Use your power rules if you have to. Drop your exponents down. Once you drop your exponents down, y'all, they're super basic equations. I really think you're going to do great with this. Go ahead and work these even numbers on your notes. Tomorrow, I will upload the key to this. It will have all the work on it. So if you do miss something, you can see exactly where you went wrong. And then all of your notes and your assignments, remember, are due by next Wednesday, the 25th at 11:59 p.m.